So welcome back guys. So in this module you will learn how to set up multi-node environment on your local machine, because this is a networking course and you will need to set up multi-nodes in order to test your networking projects and applications. So in this module we will learn how to set up multi-node topology. We will understand the subnet basics. We will understand how to configure routes in the router so that you can ping one machine from another. And we will take a look at how routing and ARP tables look like and what are the meaning of entries in the routing tables and ARP tables. So going forward, in networking we often need to use multiple machines or nodes in order to test your code, because whatever networking code that we will going to write, your code will have the functionality to send and receive a packet across machines or between machines. Therefore, there is a need to create a network topology. Network topology means a set of routers connected to each other via links. So we are not very rich, neither we are stupid. We are not rich because we cannot purchase as many machines as you want, right? So what we will going to do, we will going to create a multi-node topology environment of routers on your single machine. And we will do this with the help of virtualization software called VirtualBox. So to start with, we will create a 3-node topology. In this 3-node topology, you will have 3 routers. The name of the routers are VM, VM1 and VM2. And you can see that these routers are connected using links in between. So we will going to simulate a link between routers, and we will going to simulate the routers in the first place. And you can see that the ends of the links are configured with the IP address, and the ends of the links has a name. So the end of the link simulate an interface, the interface of a router. A router can have many interfaces, and out of those interfaces a wire goes which connects to other machines on the other end. So every interface of a router has an IP address as well as MAC address as well as interface name. So I will show you how to create a 3-node topology using virtualization software called VirtualBox, and I will show you how to configure interface name, interface IP address, interface MAC address, and how to set up the communication between these routers. So note that VM, VM1 and VM2 are routers, that is L3 routers. So before going to create a topology, let us understand some subnet basics. So as I have already explained that every interface has IP address which lies in one particular subnet. For example, in our topology you can see that there is an IP address configured on every interface of all routers, and every interface has a number after slash which is called subnet mask, right? So IP address is 192.168.1.2 and the mask value is /24. Now every interface's IP address lies in one subnet. To explain in brief, if you apply this mask value on this IP address, you will get subnet ID. We will study this formally and in detail in the next module, but for now, just understand that every IP address and mask combination falls or give one subnet ID. When you apply a mask value on an IP address, we always get subnet ID. Now, how to apply a mask value on an IP address is the subject of separate discussion that we will take up later. So every subnet has an ID and we call that as subnet ID or network ID. So you can see that in our topology there are two subnets. Why there are two subnets? There are two subnets because point-to-point links always forms one subnet. So you can see this is a point-to-point link. And point-to-point link is always in the same subnet. Now on a point-to-point link, on either end you have an IP address and the mask configured. Now as I said, when you apply the mask value on the IP address, you will get network ID or subnet ID. So when you apply the mask value 24 on an IP address 192.168.1.2, we will get 192.168.1.0 and /24. Similarly, if you apply this subnet mask on this IP address, you will get the same subnet ID. Ends of a point-to-point link always form one subnet. So there are two ends, one end of router VM1 and the another end of router VM2. And we have already seen that applying a mask value on an IP address of an interface gives the subnet ID, and if you apply the mask value on the IP address of another interface which is on the other end of the link, you will again get the same subnet ID. So in a point-to-point link, if you apply the mask value on the IP address of interface on either ends of a link, you will get the same subnet ID, and that subnet ID is called the network ID. So apply a mask on an IP address, we get the network ID. Remember, we will discuss all this subnet ID and IP address mathematics in detail in the next module. For now, I am just discussing in brief so that you will be able to understand the routing table and ARP table, and you will be able to understand how to configure the multi-node topology on a single machine. So end of the point-to-point links are always in the same subnet that I have already explained how. On either end of the links, if you apply the mask value on an IP address of the interface, you will get the same subnet ID, and that subnet ID becomes the network ID of that point-to-point link. So the point-to-point links forms one subnet. We will study subnetting and IP address maths in detail in the next module. For now, just fast introduction so that you understand how to configure and set up multi-node environment. So going forward, if you talk about this link, that is the link between the virtual machine or router VM and VM1, you apply the mask value 24 on this IP address, you will get the network ID 192.168.4.0/24. Similarly, on the other end of the link, if you apply the subnet mask value 24 on an IP address 192.168.4.2, you will again get the same subnet ID. So the ends of the point-to-point link always gives you the same subnet ID, and that subnet ID becomes the network ID of that point-to-point link. And always remember, point-to-point link forms one subnet. Right? So this is all regarding subnetting on point-to-point links.